So hello and welcome back guys. We have already learned about feature selection. So in this video we are going to introduce you to machine learning and algorithms. These are the heart of any data science model, okay? Where we train our model to learn from the data and make prediction. We will focus on tier two type of machine learning concept in this that is classification and regression algorithm. Okay. So what is machine learning? Before we dive into the algorithm, let's briefly understand what machine learning is at its core. Okay, so machine learning involves training a model to learn from data and makes prediction or decision without explicit programming. There are two major categories of machine learning. First is supervised learning, involves training a model on a labeled data set where the input has known and where input data has known output labels. Okay. Next, we have unsupervised learning. Involves training a model without labeled output. Okay, this goal is to find the hidden patterns or structured. So, next we have classification versus regression. Difference between classical and classification and regression. In machine learning, we typically encounter two types of problems: classification and regression. Classification. Here the goal is to predict the categorical outcome, such as whether an email is spam or not spam, or classifying animal into categories like dog or cat. Okay. In regression, in this case, we predict a continuous value. For example, predicting house price for estimating the temperature tomorrow. Okay. So next we have popular classification. Some of the popular classification algorithms are logistic regression, decision tree, random forest, support vector machine, SVM, k-nearest neighbor, also known as KNN. Okay. So let's talk about the classification algorithm. So logistic regression. Despite the name, it is a linear model used for binary classification tasks. Okay. Then we have decision tree. The model split data into branches to make decisions based on the features. They work well for both classification and regression. Okay. Next we have random forest, an enable of decision tree that works together to make more accurate prediction. Okay. Support vector machines, SVMs. SVM try to find the best boundary, okay, or hyperplanes that separates data points from different classes. Okay, then we have KNN, K nearest neighbor. This algorithm predicts the classes of data points based on the majority classes of its nearest neighbor. Okay, so next we have popular regression algorithm that are linear regression, decision tree, random forest, or SPR. So proper regression algorithm we have looked into, okay, no, sorry, we have looked into some popular classification algorithm. Now we are looking into some popular regression algorithm. Okay, linear regression, a simple algorithm that assume a linear relationship between independent and dependent variable. Then we have decision tree. These work simply for classification trees, but predict continuous value. This works simply as classification, as classification trees, but for continuous value. Okay, random forest for regression, an ensembled method that use multiple decision tree for better accuracy. Okay, then we have support vector regression (SVR), an extension of SVM that's used for regression tasks. Okay, so next we have example of classification problem. So logistic regression for binary classification. Let's see an example of how to implement logistic regression in Python. We will use it for a binary classification problem where we predict whether a person is likely to buy a product based on the age and income or not. Okay, so in this example, we generate a synthetic binary classification dataset using sklearn dataset.make classification where we train a logistic regression model on the training set and evaluate its performance on the test set using accuracy score. Okay, so that's it for the classification example. Then we have a example for regression problem. Okay, linear regression for house price prediction. In this, I guess, this we will, it is example. It will predict how the house prices will be increased based on the features like size, location. Yeah, okay. So we'll use linear regression in this. So in this example, we'll use linear regression to predict the house prices. We train the model using the size of the house as the independent variable x and the price of the independent variable y. We can make the prediction based on the new house's sizes. So let's move on to the conclusion. To conclude this, machine learning algorithms are the core of data science. Whether you are working on classification tasks or regression tasks, there are many algorithms to choose from. It's important to experiment with different algorithms and evaluate their performance to find the best one of them for your specific problems. Okay. So in the next video, we will discuss model evolution, hyperparameter study to improve your models, and even further. See you in the next video. Thank you.